Good evening. I am Shashi Kumar and my colleague Gopal are here today to take you through a subject on hazardous area classification and electrostatic charge. These are some of the accidents which have taken place in industries, and if you go through that, there had always been reasons because of all this non-compliance to hazardous area classification. In this case, it was a refinery in a cooling tower. People doesn't expect that there will be so much of vapors getting accumulated. A cooling tower, you are all aware of, it's a water cooling tower, and there people really don't expect vapors or petro product vapors to get accumulated in that region because it's going to be water. But in this scenario, there were issues of those type of thing, and they had a welding permit taken for it. Arc welding was going on, which generated a spark, and due to which vapors which were present in that area engulfed and created a major fire. It was widely published across many newspapers. What do you think are the major reasons for this? Is because today the lack of sufficient knowledge in zone classifications, or what you call it as hazardous area classification, is very less. Even people who are using it or usage of ordinary non-flame proof electrical equipments. What is non-flame proof is something like a normal tube light that we use in our hostels or home are called as non-flame proof electrical equipments, and there are something called as flame proof equipments. The awareness between these two itself is not really popular or not familiar with the people working in the areas. So due to the fault selection of those type of materials, it could be an compatibility of improper tube light fitting or some non-flame proof light fitting being put in a hazardous area. All these things are adding to the more problems of days. And then, as I told, lack of knowledge in features of FLP. FLP is nothing but flame proof light, or you call it as EX. It will also be called as EX or explosion proof equipments. So no proper installation and maintenance, that is also another major thing. Okay, during the new plant, everything is set right. They would have bought a new flame proof fitting, they would have put it up, electrical stuffs. But in the due course, when a technician goes over there, he would not maintain the same standard. He would have removed some glands. I'll show you some photographs of what is that and what are all the flaws. You will be able to understand much better. So in this, what you are going to see is basic of hazardous area classification, selection of electrical equipments for hazardous area, guidelines for installation, maintenance. That I am not really going to touch, but these two would be the major areas that I will be doing. Of course, we all know about this fire triangle. Here in the hazardous area classification, one thing is you have the fuel already available in a process plant, or process plant is nothing but all your refineries and everything which process the petro products. And oxygen, of course, it's here. The ignition source is one which is being added by non-selection, if you are not selected the right product in that area, this ignition source is going to get generated from that, which is going to create trouble.
So what is the significance of this fire triangle? All of you may know what is fire triangle. Okay, in our hazardous area classification, the thing is we cannot avoid the usage of flammable liquids or flammable gas, whatever we are handling in a process industry. When in a refinery, we cannot avoid the usage of natural gas or any flammable solvents. Day in, day out, we are forced to handle flammable liquids or flammable solvents or flammable gas. Can we control the oxygen? No. Without oxygen, we cannot breathe, we cannot survive. So the only controllable element is the
One second.
source.
Hold the mic.
Sorry. So the only controllable element is ignition source. Okay. So what does it mean? So for any fire or explosion to happen, the simultaneous presence of all the three elements of this triangle is very much required. To extinguish fire, we need to remove any one of the limbs of this triangle. If we remove any one, we can extinguish the fire or we can prevent the explosion. In our case, the only controllable element is ignition source. when we say ignition source, it could be electrical arc or spark or static electricity. Here, there are so many ignition sources available. Ultrasonic wave, so many, we can tell n number of ignition sources. Here in these hazardous area classifications, we will be concentrating more on electrical arc, sparks and static electricity. Okay? So to understand hazardous area classification, this we need to be very, what to say, that concept behind the triangle is, fire triangle is very much required. The only control, I am stressing this again and again, the only controllable element is ignition source. If we design our electrical equipments or instrumentation, whatever it is, that should, our ignition source, if we could able to design our equipments in such a way that it should not become a source of ignition. Okay? This is the concept behind hazardous area classification. Why we are doing hazardous area classification is to select proper electrical equipments. Yes, sir. You can proceed.
See, while studying this hazardous area classification, there are some of few definitions which one has to be clear. They are flash point, LEL, UL, lower explosive limit, upper explosive limit, then auto ignition temperatures. These come hand in hand across your HAC studies, and I'll just take you through what are they. Then another thing which is called as the flash point, flammable liquid. What is this flammable liquid? A liquid which can produce flammable vapors. Okay, what is this flammable vapor meaning? Assume you have a kerosene or a petrol, and you're going to have it in your room temperature also. You could still feel the vapors, or you can feel the smell. A nail polish or some sort of materials has too much of petrol product in them. So what this is, say for example, if you have class A product. Class A products, their flammable liquid is something where they are having a flash point which is at 23 degrees, which means at this room temperature itself, it will start giving out vapors. Say, assuming you have a petrol over here, you can easily smell it, which means the vapors are coming out, it is continuously getting evaporated since the temperature surrounding is greater than greater. Likewise, class B is at the range of 23 to 65, and then class C is beyond 65 to 93 degrees. Okay, so this is what is called as flammable liquid and flash point. Another terminology that you need to understand is AIT, auto ignition temperature. Auto ignition temperature is nothing but which it can burn by itself. Auto ignition is simple, general English, which is just going to burn by itself. At certain temperatures, certain materials catches fire instantaneously, they burn themselves. So these words, auto ignition, LEL, UEL, flash point, all these come everywhere across the hazardous area classification studies. So these are some basics that you need to be clear before moving further. Now, along with this AIT, auto ignition temperature, each product, as you will be aware, MSDS is available for each and every product. They have their temperatures clearly given over there. What is the auto ignition temperature for such and such product? So some of them are acetaldehyde, acetic acid, and these type of products. So when you are going to process them, so you need to be aware, depending upon their AIT, auto ignition temperature. Assume in this area, if you are going to use acetaldehyde or some material, then the respective nearby surrounding electrical equipment, assume you have a flame-proof floodlight fitting, and that fitting top glass, assume normal incandescent bulb, which we use in our hostels and everything. When you are going to touch it, when it is in under operation, temperature is surely 60, 70, you do feel the heat of the bulb. Likewise, so assume certain materials and they are which are placed nearby a motor, or it is transferring these type of materials. This motor or this bulb or electrical fitting surrounding it, or which can come in contact with the material, should not be very high. So what you call over here is, say for example, acetaldehyde. If you are having processing this nearby some hot steam line which is going over there, okay, steam, sometimes some hot line which is at 175, this fellow would automatically catch fire. You don't need to really ignite something or do. So that is how you select the product and the surrounding, so that the entire area is safe. That is what you do in hazardous area classification. Next, coming to LEL and UEL. LEL, as you are aware, lower explosive limit, and UEL, upper explosive limit. Just to put it in a layman's language, anything has to be at the right proportion. The mixture should be perfect so as to catch fire. If the, say, oxygen is less, or if the material, say, assume petrol or some petrol product, the quantity is very less in the fire triangle and the remaining two components are more, then it will fall in the lower bracket, where this is less mixture, or it is very less, and that you call it as lower explosive limit. When it is in this region, what happens is the air is more and the material over there which is used for burning is very, very less, it might not catch fire. When you go to the upper explosive limit is this middle line. Beyond this line, material is more rich, oxygen is less, and due to which you will again not have a problem, it might not catch fire. So, to have a right mix of the product, all the three, at this center point where between the lines, lower explosive limit and upper explosive limit, you will have this fire taking place. Or yeah.
In previous classes, we have taught about LFL, like lower flammability limit and upper flammability limit. Like
Yes.
They are the same?
Yes.
No, both are not same. Actually, lower flammable limit is less than lower explosive limit. It's a fire. Okay, when we say flammable limit, the LFL is the limit at which fire happens. Once that happens, only that will lead to explosion. So normally LEL will be higher than that of LEL will be higher than that of the LFL. Okay, but in hazardous area classification, we will talk about LEL and LFL. So when they are putting in detector LEL, okay, that time they will set the value of LEL. So
there
as
are
I pointed out, below LEL, no fire or explosion will happen. Above UEL also, fire or explosion will not happen. In between the range LEL, between LEL and UEL, fire will happen. So that's why, that is the concept you need to understand. That example
Yeah. Here if you see, you can want to explain, Gopal. Here the LEL, the percentage compositions are different. So due to which you will have the explosion range between 2.5, that is the level which.
What does it mean for each and every flammable
Product.
liquid or whatever it is, flammable liquid, that LEL and UEL will be varying. Okay, based on which flammable liquid or solvent we are handling, we need to measure the LEL accordingly. When you are putting a gas detector, we need to consider these values before putting the LEL gas detectors inside the block process block.
Assume
Okay.
here you are processing some LPG or some other product. It could be a gas. LPG could be lighter, so you need to really have gas detectors at a different location. If it is going to be some other material, then accordingly you need to have detectors values also. You need to select proper detectors. That will be helpful in LEL, UL values will help in selecting the right detectors also.
Yeah, first of all, why we need to do hazardous area classification?
Okay.
First of all, why we need to do hazardous area classification? Have any idea? Why we have to do hazardous area classification in a process plant? Why?
Hazardous classification.
Yeah.
So like you said, like we can give like welding permits and those kinds of permits depending on the zone classification. But in certain places,
We are doing maintenance, that's okay. When I am handling when I am producing any material, no? So that time why I have to do hazardous area classification? Why we have to do hazardous area classification is to prevent fire or explosion. That is the concept. That's why we are discussing here. Okay? The topic this week, what we are discussing is we have to design our equipments in such a way that fire or explosion in a process plant should be avoided at any cost. That's why this hazardous area classification normally will be done in two phases. One during design stage or conceptual stage, or during operational stage. There are two stages involved in this hazardous area classification. Okay? Clear, sir? Yes. Any doubt in this LEL and UEL? Clear, no? Already you might have been taught all these things. The reason why we are again stressing, starting from even from fire triangle to this thing is, unless until we are clear about this, we cannot proceed further. There are two things we are going to discuss here. One is about hazardous area classification. Then after doing hazardous area classification, how to select electrical equipments on the basis of the zones. Okay? Yes.
Yeah, these are the various standards which are available. It's Indian standards, plus you do have international standards which are available so as to carry out this study. So these are written guidelines on how you need to do this. It's not that I can just, for my industry, I am processing such and such, so I classify it in a different way, and that industry is away from the town or from the city limits, so I classify it in a different way. No. Either you have the establishment very near to a populated area or away from a populated area, doesn't matter. Everything is same. Guidelines are clear. If I'm going to have a vessel or a tank over here, then it calls for certain minimum clearances and guidelines which has to be followed. So you need to adhere to that. So you cannot say that my industry is located very far off, no population, nothing is there, I don't need to do anything. No. Okay. Okay, as Gopal was telling you on why this hazardous area classification and what is this all about. See, this hazardous area classification, if you see that IS 5572 which is written over there, that is the standard. 5572 and 71 are Indian standards which can be used as a guideline for carrying out this study. What is this hazardous area classification tell us? It's an area in which explosive gas atmosphere is present because you are processing the chemicals or whatever. So carrying out hazardous area classification is area in which an explosive gas atmosphere is present or may be expected to come during the due course of operation, meaning you have a pipe or a flange or a motor. When working on that motor, there are chances that you open a flange or a motor, there could be some residual material in the pipe which can spill over, you collect it in a bucket, transfer it. So it is actual condition that liquid is not going to flow down, and in abnormal condition when you are carrying out some maintenance, there are some chances of spillage, a barrel can topple. So all these things, area in which an explosive gas atmosphere is continuously present or may be expected to be present in quantities as to require special precautions has to be taken for that when you are handling to the construction, installation and use of equipments reference to hazardous area, meaning in this all this is because this entire plant is hazardous. One, you are going to process in a vessel, so you are going to have the right electrical material, or if you are having a pipeline somewhere in the tank farm, there are tendency of leakage or when you are going to open up, so there also you need to do. So in the due course of operation also it might appear that there could be some leak or anything. So all these areas wherever you might handle, process or there are chances of leak coming out has to be covered under hazardous area classification study, that which is called as HAC, a method to analyze and classify explosive gases environment into zones based on the frequency and duration of explosive gas. It also depends upon how many times, frequency and the duration. These are some terminologies. Duration is again time dependent, frequency is how many times it had occurred. Say assume I have a barrel and a flange leak, it has just hardly a drop has come down and this pump will never leak, you are for sure. So it also takes into consideration those type of parameters also. How long this material is going to be. Assume you are dispensing 100 liter from a PET bottle, taking it in a beaker, going and doing some process. This addition takes place only once in a month in this room. So will it call for classification since I am handling a hazardous material? So you can analyze this, all this put together. Certain areas just doing this also might not fall in HAC, meaning hazardous area classification. For this small one operation, you don't need to entirely redo this room so as to meet flame proof standards or hazardous area classification requirements. You don't need to do that. So all those things will be depending upon each and every operation that you do in the process, that will let you know, and thereby you classify this as whether it is safe, unsafe, or you can use non-flame proof or flame proof. So all these things comes up through that. Where all this HAC studies would be carried out, do you think? A wild guess? any process plants. Process meaning what? All petro products.
Any process in in
Where-
addition to what Sasi told, any process industry which handles flammable solvents or flammable gas day in day out, they have to go for hazardous area classification.
Take it right from your nail polish to your makeup kits or some sort of material, to your paint that you use in your home, to your medicine that you consume. Everywhere you are going to have all these type of materials handled. Only the proportion and the quantity may vary. Okay, in a refinery I might 100% use a solvent or a toluene. In a nail polish industry they might use just a barrel or a quantity so as to run the production. But still, or for a paint industry, solvent paints which are used on metal coatings, there also you can feel that smell. All these industries would go through pharma. All these would go through this hazardous area classification study. Now, coming to zones, as I told that in hazardous area classification, what you are doing is classifying the hazardous area into various zones. So, in this there are 3 types of zones: zone 0, zone 1 and zone 2. Now, take this typical example of how much of you have seen at least some solid tank farm, any tanks which stores diesel or some sort of tank. If you have not gone through industries, when you are going through some railway line crossings, you could have seen on the roadside some big large tanks which are there. What they really do is they get the crude or whatever or refined product, they store it in their tank, from where they dispense it to small lorries so as to go into, I am taking the best example of all our petrol bunks that we all go across and see. So, you have a tank say somewhere on the rail siding or by the harbor somewhere, where you have that material getting dispensed from a ship or crude or whatever. From there it is once again transferred from the pipeline to a lorry tanker which comes out. Now, take that typical example which everyone can understand. Here zone 0 meaning what? Zone 1 and zone 2. Zone 0 is nothing but where there is continuously vapor present, meaning if I have a barrel, if I have taken 50 liters, a barrel is 200 liters capacity. In this petrol or a diesel, what I have 50 liters I have taken out. So, that 50 liter volume is empty over there. Continuously inside, after closing the barrel, continuously there is going to be vapors generated present inside the barrel. Assume this barrel to a tank, similarly of a larger capacity. So, this tank, what you have inside, you have the material, assume 20 kL of material is there, there is another 10 kL volume free. So, always it is in the open, meaning the shell by itself would be having some 30, 25, 40 degrees. So, that is something called as what we discussed in the beginning as flash point. So, all these materials will start evaporating. Only thing is it might not fully come out. So, everything would still be remaining inside. Okay. So, this is continuous presence of vapor. Where a zone has continuous presence of vapor, you cannot have any electrical equipments, and that area is called zone 0. Zone 0 meaning 0 equipments, you have it like that, but you can still have instrumentation, certain sophisticated equipments. Zone 0, 0 electrical equipments, you cannot fit in any stuff over there. So, that is zone 0. Then what is zone 1? So, that is zone 0 which is now highlighted. Then zone 1 is what? You have this tank or a barrel ka mouth hai, you open it up, from there you will see that around the opening of the barrel. So, similarly around the small dipstick level where I take a daily monitoring reading, there could be an operator who goes stop and take a reading. For that they will give small opening. There could be one level indicator, or there could be a manual hatch door so as to open or see, or for once in a while cleaning, where there are nut and flange and bolts. So, these areas around them are called as zone 1, where there are chances of continuously it is not present, but once when he is going to open it, there are chances of vapors coming in that area, and this also frequency is more, and it is not that continuous, but frequency, meaning I do this weekly once or so, I take the readings. So, accumulated hours in a year could be so much number of hours, based on which I am classifying it as zone 1. Then zone 2 is all the surrounding area around that is called as zone 2. And examples, okay, as I told, inside the tank, then you have the where the hatch door or some instruments are fixed on the top of the tank, those areas would form under zone 1, and above zone 1 you will have zone 2. And assume if there is a bund or dike. What is a bund or dike? You have heard this word? Okay. A bund is what? Assume this is a tank. Always so as to contain the spill, something happens to this tank. Assume a bottom valve opens over here, which is connected to the pipeline or a pump. That night some flange cracks, or the dead volume over there somehow leaks from the tank due to some pinhole. So around the tank there will be a wall, which is called the dike wall or the bund. This would be used so as to contain any spill. It will not be an open level flooring where something leaks from the tank. It should not happen something like the recent Ranipet incident or a Bhopal. Ranipet incident was something like a bund only. Have you heard of the Ranipet few days back? In the ETP what occurred was a sludge which was contained in a wall, and that actually broke the wall and everything came out to the streets. So here this is a tank. Around the tank you will have a wall which is not to the full height. It will just be at the base level only, few meters height, 1 or 2 meters height, so as to hold the volume of material inside the tank, and when there is a catastrophe or leak, it will get well confined within the tank, within that bund wall, a pit wall around the tank, and from there you divert it to a separate pipe where there will be a bottom valve opening and so. So that area would also be classified, because though my tank is not going to rupture tomorrow itself, it does not mean that I cannot classify that area, because in that area I might have a motor or a flange or a pipe, something over there. So someday when I am going to do a maintenance work, I remove, there could be some spillage taking place. So that is what is called the dike or bund wall around the tank. So that area also would be classified. Yeah. 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 This is what I was telling on how do you, one way is this on the number of hours in a year. Say assume this can be literally replicated in your laboratory. As I gave you an example before, I do this manual operation every 1 hour once. I do this, dispense it, take this material from here to there, add it in that product. When I am taking this material from here to there, it is continuously present. This operation takes 5 minutes, but in a day I do 10 times. So it is totally 50 minutes. Then in a year, so all this put together, if this area, if I need to classify it as zone 0 or zone 1, it should fall greater than 1000 hours. So this, if I am going to put together, if it is going to come only to 500 or 100 hours in a year, I might move this to zone 1. So those ways we classify that. Okay. Another major thing that one has to know is, all along we had been talking on what is or what areas needs to be classified. There are certain areas, though you handle solvent, need not be classified. How is that? Assume I have my tank on this side. This is my admin building or my office building. Let us assume our building itself over here. I have my storage tank there. I have my process or my plant on this side. What I do from here, I pump the material. My pipelines are all going above this building and then finally being used in the process on that side. So there is a question whether I need to classify this building also, because materials are being transported. No, it's not required. So there are defined guidelines how and where you need to classify, because if this pipeline above this building doesn't have any flange or any sort of nut and bolt arrangement, if it is fully a solid single pipe from there to here, in between, if they have, instead of a flange, they would have welded it neatly so that it will never leak, then you don't need to classify anything. Okay? So these are some of the examples that I am telling you. So there are certain pros and cons where you can, as per standards, certify and say these areas need not be classified. So generator, diesel generator is another example, because it's an internal combustion engine. So diesel flows inside, everything burns inside, and it's fully tightly shut. It's something like an engine car or whatever. So you don't need to classify that, because it has met the safety norms. It will ensure that there will not be any leak from it. Whatever fuel goes inside will get burnt fully. So those areas all you don't need to classify. So these are some of the examples where you don't need to classify those areas. Okay, now coming to, if you see an hazardous area classification drawing, it will just look like these checked boxes, dots, and single hash, double hash, and dots. Based on this, you will get to know what is zone, which is what, and zone 0, zone 1, or zone 2. Okay.
This one, circle with this one is for zone 0.
Zone 0.
That is for zone 1. This one is for zone. As you can see the drawing, if you have looked at the, only this zone 0 will not be classified in the drawings. You can only see this zone 1 and zone 2.
Zone 0 is understood, it's going to be continuously present. So you don't, if you're going to hatch it inside a vessel, which is, or a barrel sort of drum, so it's not going to make sense over there. So normally these two would be hatched and given. And it's, okay, so far what we saw was as per standards. There are other factors also which determine whether to classify the area as zone 0, zone 1, or zone 2. That is based on the type of ventilation. This room has one side window, the other side doesn't have. Assume this as a lab. If I open both this side window and this side window, there could be a perfect cross ventilation. Go to a petrol bunk. Petrol bunk is just a single roof standing, or there could not even be a roof. So when he's going to dispense fuel, whatever vapors coming from it immediately gets diluted and goes. You will not have a fuel pump or a petrol station coming inside a complex, you fill it, not inside a closed room, no. You don't have it inside a multiplex or all those things. Why? Because all these vapors, so much of filling operation, immediately it has to get diluted. If not, what happens is that area would become so concentrated. You can, have you felt when you are filling your bike or anything, there itself you will start so much of fumes coming. And assume 100 bikes getting filled over there, and if that is not going to get well ventilated, diluted, it can immediately catch fire. So these factors also play in a role so as to dilute or what to say, bring down the levels. So when you are having a proper ventilation, then a zone 1 area can be classified into zone 2. Those type of all these things can be applicable. If there is no ventilation, then I put in a blower or an exhaust fan mechanically continuously operated so as to pump in air, dilute the area, meaning this is a lab. Here I don't have open. So I need to have an external vent or say FD fan, sort of some fan which will pump in more volume of air, take out that immediate vapors coming out, dilute, and have the room neutral without any much of vapors in it. So based on the type of air and ventilation properties also, hazardous area gets classified. So meaning the level or intensity can be reduced. From zone 1 I can move to zone 2, and from zone 2 I can totally move to safe zone. So I can keep changing depending upon volume of air flowing in that area. Yeah.
You give the example of petrol bus, so it's in a closed room. Say it's very concentrated, so the mixture will be too rich for explosion, right? So if you pump in air, wouldn't it be adding oxygen and bringing it into the...
First and foremost, you will not be allowed to keep a petrol bunk in a closed room. Assume sometime it's not rich in mixture. Rich in mixture is say at the 100th two-wheeler that you are going to fill. At some point in level, it would have crossed from LEL level to say 30th bike I am going to fill. At that time the vapors could be different, 40 two-wheelers different, 50 different. Only at 100 or when the volume inside the room totally becomes rich in mixture, then it might not catch fire. But before that itself it would have started somewhere or the other. It could have caught fire when there were only some 20-30 bikes getting filled. Okay, so you will never have any petrol bunks in closed condition. If it is so, then it is really dangerous. And they will also not give permission for such type of operations to be carried out. So I am just taking the best example which everyone can understand right away.
In any industry, they will not allow UEL to be formed. Okay, that's why they will put detectors, LEL detectors. Normally, the detectors, gas detectors, will be called as LEL detectors. LEL, for each and every flammable liquid or solvent, there is a value LEL to UEL level. When they are handling that particular solvents or liquid, they will set the value 10% of LEL will be set as an alarm in that gas detectors. Once it senses the 10% LEL, it will give an alarm that there is a chance of LEL formation inside. So after getting that value alarm, they will take some necessary correction action. Okay. If that doesn't happen also, they have given 20% LEL will be given as a trip. So even after taking the 10% as alarm, someone has forgotten to take an action or some other thing, after getting the 20% LEL value as a trip, it will trip all the electrical, all the ignition sources inside that particular block will be cut off.
So all
In
those
any
are
industry, they will not allow the formation of UEL inside any process block. Okay, that's why the detector, wherever in a strategic location, they will place gas detectors, LEL gas detectors. The value is 10%, 20%. 10% alarm, 20% trip. Clear?
okay.
So,
Yeah.
before getting into these electrical equipment selections, you may be thinking why I have to do in a process plant. It's not hazardous area classification, nothing but we are dividing a plant into zones. There are 4 zones. Normally we'll call it as 3 zones. The 4th zone is nothing but area unclassified or non-hazardous. Okay. So when we are classifying into zone 0, zone 1, zone 2 and unclassified or non-hazardous, whatever it is, you may be thinking why you have to do all these things. Simply straight away I can put equipment suitable for zone 1. Zone 0, it always happens inside the tank. Normally it will not happen in the outside of the plant. It happens, depends on the availability of ventilation. If the ventilation is very poor, even we are classifying that area into zone 0, that will become zone 0. I already has explained that to you. So if you may be thinking why I have to do all these things. Straight away I can put equipment suitable for zone 0 or zone 1. Yes, we can do. But what is the cost? What would be the revenue we are incurring? What is the revenue loss? It could be a over-engineering design. Okay? In order to select equipment suitable on the basis of zones, we are doing this exercise. Okay? Clear? Yes, sir.
Yeah, as Gopal told, see, you can just go as a blanket zoning. Blanket zoning is, I assume that this entire IIT campus is, say, zone 1 or zone 2. Straight away buy the highest safety product, install it, go, I can still be safe. But EPC, or you go to a refinery, or simple example of this hostel you take, how many tube light fittings could be there in this building? And assume if I am going to ask you to change this tube lights to flame proof tube lights, a tube light is just hardly 40 rupees bulb and a fitting is 150 rupees. If you are going to change this to a flame proof fitting, the fitting alone is going to be 2,500 to 4,000 rupees. And then what is the cost of maintaining it? Person going, there could be 20 Allen screws. By the time he opens it, does everything and come out, it will take at least nothing less than 1 hour to finish replacing one tube light over there. Even if he has all the right tool over there, he will not be able to do it. You cannot just, that's the reason you will not be able to just like that simply blanketly say, ठीक है यार मेरे पास capital paisa hai abhi, for now I have so much of money, I will invest, I will buy all flame proof safe products, but no. EPC is also, everyone is running on cost. The amount of that I expend over here has to get returned in next 1 year, 2 year to me or to the company. They need to generate profit. If not, so that's the reason they try doing the best of the design, saying how much ever possible we'll try handling in that area alone, remaining area we'll try to have it as normal light fitting or normal whatever, non-flame proof. So everything is cost to cost implications are there. So here we are going to see what is the equipment, electrical equipment selection, as he was telling, depending upon zone 0, zone 1, zone 2, what type of equipment you will install over there.
This is the question for you. Can you use this wristwatch in hazardous area? It's a simple electronic watch. Can you use it? Yes or no? There are 3 possible answers, yes or no comments.
No.
No? Why? I need answer. Nothing wrong, sir. You can come out.
Yeah, I'm thinking. Battery that you're using, if it creates by chance a simple small static charge or little spark will not be there, but static charge, because of the metal it is there.
Fantastic answer. That whatever you are saying is correct, but there is a limit for that. Okay, as long as your battery is less than 1.2 volt or less than 0.1 amperes, 25 milliwatts, you can use that. Suppose if your battery is having, suppose you are having an electronic watch with lithium battery, then we need to do risk assessment. So most of the industries, process industries, they will not allow you to wear even electronic wristwatches also. So if that is the precautions they are doing, means whatever the installation they are putting install, how much care they have to do, how much thinking they have to consider before putting in any equipment, any FLB electric.
You cannot take any cameras, cell phones, everything is out. Whatever you are going to use would be only called as intrinsically safe, or it has to, or it should meet the flame proof requirement standards. Okay, so this session we will be seeing on selection of equipments. Have anyone seen motors? Motor. Water pumping motor or anything. Okay. Have you gone through in your electrical during those days in your lab or electrical lab, if you had come across, there is something called as nameplate rate details? Okay, nameplate details, if you have not seen it, at least go back now and see what is a motor somewhere in your hostel area or blocks, and then see there will be a nameplate which will be stuck on the motor. On that motor there will be so many details which will be present.
This nameplate is for FLB electrical equipment, FLB motor.
Forget about this FLP or whatever.
Different.
Since I am not going to, since you have not seen the motor, so I am not going to go much into it, but there will be something called as nameplate details stuck on the motor. And if it is a flame proof motor, you will find all, here you might not have any flame proof, but for a normal motor you will still have voltage, amps, what is the efficiency, at what voltage you need to operate, ambient temperature, all these things will be there available for a normal motor. These columns, temperature class also would be there for the motor, but the value will vary from motor to motor depending upon the application. So this temperature, IP class, then gas group code, whether it is EXD. If it is a flame proof, then you will have this. If not, you will not have this symbol. So this is a nameplate of a normal flame proof motor. Once you come across someday when you go to an industrial visit or somewhere, just look for a flame proof motor. Or inside your campus, if you have some diesel storage yard, tank where diesel is transferred, those motors might have or should have this. If it is not having, that itself is a problem.
No. Why we are showing this nameplate is, don't bother about this nameplate and all. After this session, selection of electrical equipments, you can easily identify when you see the nameplate of FLB equipment, you will understand what is the type of configuration, what is the gas group, what is the temperature class. When you have a look at that equipment nameplate itself, you will be in a position to understand what is there.
Right.
Okay.
Yes, sir.
Okay. The selection of electrical equipments in hazardous area and mines, all these, even a mine is an hazardous area, because that is where you have all various gases which are getting generated and it can create trouble. Okay. So all these are being dealt in Indian standards 5571. Selection criteria will depend upon hazardous area, temperature class, gas group. I will just take you through what are they. As we previously discussed, these all parameters will be available on the nameplate. So by reading the nameplate, as Gopal said, you will be able to understand whether this motor can be used in which application, which location. So one, you need to look at the nameplate detail for T classification. So this T classification is temperature class. If a motor on the nameplate, if you are going to see T1, then what it tells is the motor can reach a surface temperature of up to 450 degrees. Okay. Or it in due course or somehow it can, either it could generate that much of heat. That is what they meant to say that. If it have, so T5 example, then the surface temperature can go up to 100. And if it is a T6, it can go up to 85. Do you see the correlation of this T class with AIT? What is AIT? Auto ignition temperature. So there is a relation between the T class and AIT. Auto ignition temperature is what I said, that these materials can catch fire by themselves when they come in contact with certain surfaces itself. So assume I am buying a motor of say some T1 or T2 or T3, which is having a which can go up to 200-300 degree temperature. Put this in an area where a material is being processed and its auto ignition is 140, what will happen? It will immediately catch fire when there is some small spillage on the motor or something, isn't it? So, if my auto ignition temperature is say somewhere acetaldehyde, we were seeing that 175 is my auto ignition temperature. In this area, if I am going to go and put some T3 or T2 motor, I have told that T2 and T3 can go up to 200 and 300 degrees, whereas my product auto ignition temperature is 175. So, it might immediately catch fire when there is some spillage or anything. So, this is how you rate or what to say AAT with the T classification.
So, in addition to what Sasi said, so these equipment, so this temperature class, what it says, when you say this equipment is with the temperature class of T3 means, these motors or electrical equipments are designed in such a way that even if there is a malfunction or coil burnt out or bearing rubbing, whatever may be the reasons, during normal or abnormal conditions, it is designed in such a way that the maximum surface temperature of that equipment will not go beyond, suppose if it is T3, it will not go beyond 200. That is the assurance we are getting from the OEM or manufacturer. So if I am handling acetaldehyde in a process block, in a refinery, process block A or block B, whose acetaldehyde's auto ignition temperature is 175 degrees Celsius. So that if I select electrical equipments of rating T4, T5 or T6, T4 is more than sufficient because its auto submission temperature is 135. So I am restraining that EQ, okay. So I can select T5 or T6 also. T4 is more than enough, but even if I select T5 or T6 also, that's okay, fine. But that is over engineering. Suppose in otherwise, so if I am selecting T2 or T3 or T2, T1, if there is a formation of wafer coming out of that acetaldehyde, when it makes contact with the surface temperature of that equipment, it will create explosion or fire.
It's called value engineering. You need to right size the material or the motor or the equipment so as to exactly meet the requirements. You cannot over design or do an under design, isn't it? So every money that you spend is really should be worth it. So you cannot oversize or go to a next level of higher range of motor. That motor could be another 5,000 rupees extra, but for us, for one motor it could be different, but when you go to a refinery there could be thousands of motors. So they cost straight away jumps. So they will see to that point wherein everything is designed to the perfection. That's what is process safety all about.
Suppose they are handling only one chemical, our life will be very easy. We can straight away select this one. But if they are handling multiples of solvents, then what shall we do? So what they will do, they will select the minimum temperature, mostly T4 or T5, based on which chemicals they are handling, whose auto ignition temperature, what is that auto ignition temperature, what is the least AAT, based on that they will select the equipments. Clear? Yes. Yeah.
That's all. Depending upon their AAT, you have an EXD temperature. T4 or T5 can be product.
For petrol or diesel also AAT is available. It's if I remember correctly, that's coming around 200. So normally what they will do, they will select equipments of T4 or T5 or T6. Mostly it will be in the range of T4. Okay, when you are selecting the equipment, three things we need to consider. What is the zone? In which zone I am going to put that equipment? Then what is the AAT of that flammable liquid or solvent I am handling over there? Then what is the gas group? Gas group we will be discussing in the later. Now the next slide is gas group. Okay? Yes.
Yeah. Previously we saw on the temperature. Now this is on the gas group. So gas group, they have classified this into three, which is 2A, 2B and 2C. So 2A is all propane, ethylene, and then 2C is hydrogen. Here there are certain parameters which are, there is a reason behind specifying the gas group. The reason is this maximum experimental safe gap. When you design an equipment, you cannot say that I have completely sealed this equipment, or take for example a jam bottle or any bottle or sort of a, when I am going to twist it and put it, there is always few milli mm or what to say, less than 1 mm or 0.5 mm, some gap is always going to be there. For a vapor, this gap is more than sufficient for it to go inside. Okay, so that is what you call it as the gaps, safe gaps which are available for those type of products. So if you see, if you are going to handle hydrogen, here it is more critical, and the gap available over there will be totally different, and the construction also would be different. So as to, in any explosive product, the next section is also on that only. Always you are allowing the vapor to go inside. There will be minimum gap. Through this gap, vapor would go inside. Internally there is a termination, or what you call it as the electrical connection, which is available. Electrical connection meaning surely it is going to give out little bit of spark here and there when I am going to start a motor, switch on off, all those things. So what happens is, when these vapors go inside, when this switch is getting switched on, there will be a minute spark which comes up. Due to that spark, the vapor which has got accumulated within this enclosure will immediately blast. Blast meaning it is a very small explosion. That explosion would be contained by this electrical flame proof fitting itself. This fellow will not crack or blast and create more trouble. It is made so as to withstand that small minute explosion which takes place inside. It is something like normal, hamara ghar pe we have this normal domestic switches. How much time you have witnessed a small spark coming over there? When you put over there are chances of spark, but it can still withstand that burning capacity, but still you would have used it 10 times, 100 times. Likewise, a flame proof enclosure button also will create a spark inside the housing, but that spark will not come out of the housing and come to the surrounding area so as to create a major explosion. What will happen is, something happens inside, it will happen, the time taken for the gas, the construction by itself will be like encapsulated like one inside the other. So it will take more time to come between the layers. The gas would come after it got small explosion, it will try coming out slow. It might not have, so by the time it travels longer distance and comes out, everything will get quenched and only a cool air would come out. By the time that cool air, when it comes out of the enclosure or some electrical fitting, it is not going to create any hazard, any trouble to the surrounding area. So enclosures are made to create a small explosion within themselves. Like any normal domestic switch that you switch on, there will be a small spark. Likewise, within the enclosure there will be cable coming, termination would be there, small spark might come, but that spark will get quenched inside the housing itself. So what I meant to say is, these are gaps which are specifically to be maintained. So it's not that I bought this material which has a 0.9 mm which is pertaining to gas group 2 and use this product in 2C area. Understood why? Previously last slide was on temperature, this slide is on gas. Assume in this area you are processing hydrogen, then you need to go to the next level of, first you refer the T column, then you go to the gas group column, and then you go to the next level. So after you need to select all these three, put together, check for the nameplate, and then use the right equipment. So if you are going to use propane type 2A material in 2C area, then again it's a wrong selection, it might catch fire.
So what makes you decide that for 2A it is 0.9 and for others it is 0.5 to 0.9? What basically decides the gap? Is it the nature of expansion of the gases present? Or
Yes.
Is it,
How hazardous it is and its molecule size by itself, it's all together a design by itself.
For each and every gas that is converted in based on these values, MESG and MIC ratio, minimum ignition current ratio, based on these values for each and everything there is a value available. Based on that, the gases, when we say gas or vapor or this one, based on the values, these are grouped into 2A, 2B and 2C. Hydrogen is the most dangerous gas. Okay, stringent. As you can see, the value is also very less.
Product manufacturers do this. Our job is to rightly select the product. A product is available for a hydrogen, then buy that product only. That could be 5,000 rupees. A product for a propane could be 2,000 rupees, but it doesn't mean that we, leverage on the cost and buy for this, but both might look similar. flame-proof equipment, both might look similar, but both has its own function. So you need to rightly select the product depending upon the application area that you are going to use.
See, 2C equipments can be used in 2A or 2B or whatever. There are these two locations, but the reverse is not true. We cannot use 2A in 2B locations or 2C locations. 2B can be used in 2A also, but 2B cannot be used in 2C location. Whereas 2C can be used in 2A
C is
or
a
2B.
stringent, but again it's going to be a cost factor which is going to go into it, so you need to be playing it safe on selection. Yeah.
What is the experimental setup?
Yeah, time over. Let's wait for.
MESG, that will be done in the lab situation.
No, I'm saying, what's it?
Yeah.
Yes.
You asked for what is this experimental gap. What happens is actually and assume this is the enclosure top. So what happens is some explosion or some termination which the cable goes over here and you are terminating it with a gland. Here you have the connection. What happens is after a spark gets created over here, the top enclosure also would have so much of step which would go inside like a vessel and it will be kept enclosed. So what happens during any of a small explosion is the time taken for this spark to come out of this is the small gap that I am talking between two top cover and the bottom housing which we have fixed. So the time taken for this explosion, after once it gets exploded, it will take more time, travel time path is more. By the time it comes to the surrounding over here, what happens is gas has totally got cooled and it will just be only a normal some sort of gas coming out. So no flame or anything comes out of an fitting or a junction box you call it. So over here this safe gap is actually, it's for if you are going to use in such and such area, then these type of fittings would be available. You are able to.
Design is of the switch that you use in household.
This one.
Switch. Yeah.
This is not, or you call it a switch, or assume this to be a circular junction box. Assume this to be a cover for a box. And here you have the cable termination. I can show you some images where on the later part where the same thing I can replicate. I will show you those images. It will be much more clear for you. You can go to next. Yeah. Okay. So assume this, as I told, this is sort of a LS of a junction box. Okay. Whatever. So there, this equipments are classified, as I told, into various, again subdivided into EXD, EXE, EXP, I. So various subdivisions are there. So EXD is type of construction is rugged, flame proof, and then if you go to EXP, it is pressurization. Say for example, here the spark is there, there will be a continuous air pressure which will be going so as to carry the total spark, not the spark literally, after it has got cooled down, the material will get immediately carried away by the air which is there. Assume if you go to some process plants, they always have two different or a DCS room. What happens is there, DCS you are aware? Some control panel room, assume. Okay. If you go to a server room like arrangement which will be in process plants, there will be first door, you go inside, that door would close, this area would be pressurized, air would be continuously blowing, this door will get closed. Then I will go to the next door, open and come back. This is because there will be two doors of separation like this room. We had, I think there are two doors. It is just to segregate this hazardous area into a safe area. That area could be, you might be handling some other materials which is safe, or it could be your office space, you might use heaters. So in an equipment also you have
this pressurized equipment. What we are doing, we are sending a inert gas inside the equipment. It's an ordinary equipment. Equipments are electrical arc or sparks will happen, but we are forcing the inert gas to get inside.
Go through it.
It's a closed cycle, okay? So even if there is a, it will not allow any spark or arc to happen inside because we are putting a inert gas inside. It could be nitrogen or any other inert gas. Okay.
And this intrinsically safe is, these type of instruments are used in zone 0 itself. As in the previous case I was telling you that inside a tank there will not be any instruments. No electrical instrument, but in instrumentation type like level indicator, what is the temperature indicator, all these can go inside the tank itself. There it is instrumentation which is available. Here there are some Zener barriers which will minimize the voltage to such a low levels that it cannot create any explosion or anything. Then next is oil immersed. Here the electrical device is immersed in an oil. It is something like a transformer which is immersed inside the oil, and that oil would be dielectric in nature. And then here it is powder filled. Powder filled, have you broken any switch, fuse, electric fuse, HRC fuse, if you see inside there will be quartz sand filled. So when you break open that, inside it, any spark which comes, because the sand is fully filled in it, immediately it will quench that and the fuse will not literally rupture or come out. So that type of thing. And this is a PCB molding, wherein M stands for, if you see certain printed circuit boards, what they do is, once the components are placed and everything, there will be a printed mold which would be fully poured on it, and it will nothing, no component would be visible. And plus it will act as a intrinsic safe between, one fellow will not be able to touch with the other because you have poured the mold in it. Assume there is a capacitor, there is a resistor, there is so many electronic component devices. What in certain hi-fi generators or anything is, they pour the mold so that nothing gets loose. One fellow will not be able to touch the other fellow, no short circuit or anything will happen, no spark will get generated. Everything is quenched and safe. So these are other ways of how they protect the electrical equipments in zones. Now the selection, as we saw that EXI, EXA, EXN, so all these are the type of protection, what you see on the nameplate of the motor, where it can be used, whether zone 0, zone 1 or zone 2, conforming to IS standards, all this would be available over there. This is a flame proof box. What happens is, actually there is a mixture inside because it's in the process area, so the mixture vapors would go inside and get accumulated. When there is a spark, something like this which is occurring inside, this entire stuff, every time you on off, what we do in our home also, similar application you just imagine, there is a spark generated inside. So due to that, the entire box will explode internally, but it can withstand that explosion and then finally send out only the cool air, and that which will be safer even in the surrounding. That's how this flame proof equipment is protecting. Next is, now these are all the various laboratories which are available, who are the authorities or the authorized bodies to test all the flame proof equipment. Manufacturers, after doing their manufacturing their product, get it tested through these labs or these agencies, and which is then comes to the market. So what we saw now was, this is what you see over there on EXD 2C T6. T is the temperature that you see, 2C is gas group code, EXD is a flame proof. So these all put together will be available on the nameplate, based on which you can say whether you can use this for hydrogen area or for a propane or water type of material, depending upon gas and temperature all put together. You read this nameplate clearly. These are the manufacturing statutory authorities who control them. Now coming back to the nameplate detail on a motor. So as we discussed, you will see this temperature, you will see this gas group, you will see protections, whether this is EXD type or EXN or EM and all those stuff. This data would be not only available for a motor. it might be certain details would be available for any normal. If you are going to buy a light fitting also, you will see that product. Even if you buy a small junction box, you can see. I buy a flame proof telephone which I am going to use it in process area, I can get this. Might not be that RPM, all those devices, nameplate detail might not be necessary for it, but you will still find this gas group or EXD or all those stuff. Okay. Now coming to this, and this is what a typical flame proof equipment is. Say how big the equipment, a small junction box, if you are going to use it for our house, is just hardly say 10 centimeter by 10 centimeter. A ceiling rose, or I could not locate one, something like this, itna bada rahega, so big. Or assume that also to be a junction box which comes down your junction box is what, just two connection, isn't it? But when that goes to a flame proof, size becomes almost 4 to 5 times bigger, because the reason is it has to withstand the explosion which takes place inside. This is sort of a junction box, this is a terminal junction box for a motor. So all these are, this is how a big junction box would be, the round one. This you can, next time you go to a filling station, you will have some street light inside the petrol bunk station. Please note for this junction box on that. Surely you will have this. This is the junction box from where one side you will connect it, from here it could go to the street light pole, tube light, which is inside the petrol fuel station. So this junction box by itself, you can see, will be very big. Okay. Okay, this is just a comprehensive chart which we have prepared. We can share it with you on how you select and all those things. That was all about hazardous area classification, basics on hazardous. And now what we'll go through now the static electricity. So far so good? Yeah.
Any doubts or any clarification you want from us?
Right. Yes. So what we saw was AIT, temperature, gas groups, then equipment selections. Okay. Zone 0, zone 1, zone 2. Now coming to the static electricity. In this we will be having introduction on electric discharge, static electricity, measurement of charges. All this we will be seeing in this. All this hazardous area classification, static electricity goes hand in hand in process safety or process plants also, because without this, any product, you are going to have these issues. All the products will generate static charge. Right from our school days, we would have read much and much about the static charges, and nor even the kids, as a kid we would have played with so much scale and a paper throwing on it. So static charge is something part and parcel of our life in our day to day, but when this comes to a process plant, things are much more dangerous because of the static charge. So here we will see what static charge is all about and how is it, why is it so much of importance given to it in a process plant. As we all know, any product or matter has both positive protons and these electrons. So when there is a transfer of, when they are transferring one charge or the other to the nearby atom, you are going to create this static charge. When either you are having more protons or more electrons, you are going to have discriminations in the charge, which is really going to cause this issue. These are the various materials which we would have also seen in our younger days, where this is relative to electronegativity ranking. If these type of material, when a glass is rubbed with, all these are positive, are electrodonators, meaning they will be able to give out more electrons from them. They try to always become positive, whereas these materials always tend to become negative. They will accumulate more electrons, give out protons. These are the product by itself, product specifications, and they tend to behave in that manner. So all these materials like copper, rubber, PVC, Teflon tend to give out protons and they become too much of negatively charged, whereas these materials give out electrons and become too much of positively charged, or they take more positive protons to them. So how is this related to our process industry is something where we are going to. In static electricity, few things that one has to understand is on the insulators and conductors. These are the two terminologies which will be coming again and again, which you know the definition, which is conductivity, meaning which can easily conduct, transfer takes place, all these things. Why is this static discharge importance in process safety? Because today in the current text, whatever industry you go, there is no material which is prepared just by homogeneous. It's always a mixture of two different products or three different products. It has to go through some process where you have a stirring operation or a mixing operation or a bag dumping or a pneumatic air conveying, or it is pumped through pipeline, something or the other. It's not that I have this product, it's just homogeneous, I take it and use it. No. Today, right from food products to medicine to anything, it's actually a mixture of so many compounds, mixture of materials. So when two, three different materials, all you cannot expect them to behave in the same manner. Like we all are by itself separate. I might not be able to simply if we need to say there is always some friction over there. So when two different materials over there are being mixed, there are tendencies that certain products would behave differently. So as we saw the scale from glass to Teflon, certain products will give out electrons, some would give out protons. Thereby it always doesn't be neutral. You need to try reducing that and try to bring all materials to neutral so that no issues are there. So what happens over here is, if you are not going to do that, then all these things will occur. You will have spark generated. These are various forms of discharge. One could be a spark, one could be corona, then you have brush, you have propagating, cone discharge, lightning, like discharges. So for us, we all read it as static charge, but this is once again subdivided into so many. Now, what is the static discharge? How much of you felt the static charges? Have you experienced static charge? Anytime? When you go touch a metal door, all of a sudden, sometime when you touch your car doors, you feel as if you receive some shock. Not the shock that you receive in your knees. Sometimes you hit against, you find the shock. There is something separate. Or you switch off your room light, bedroom light, and your blankets, you do something, there could be some small sparks sort of things.
When you wear woolen clothes.
Woolen clothes, start rubbing some on, you would have been sitting in your car for such a long time, and then when you come out and touch a door, immediately steel products you might experience. So all these are nothing but minor. You go touch a fridge door, you might get, but that might not be really electrical shock, but actually it is, because entire day you would have been working, rubbing all those things, and finally when you're going touching the door over there, all of a sudden you would have felt like a shock. You might have even thought it to be an electrical shock. It could be also electrical shock, but this also is, chances are there. So that is our day-to-day routines. But when it comes to an industry, the things are all in a larger scale. What we see over here is all small. Even that small spark is just fractions of second, which nothing is going to happen. But that fraction of second small spark in an industry can be devastating. So how do you reduce that so as to make everything neutral? Simple is grounding, bonding. Static electricity and bonding go hand in hand. If you are not going to bond, earth it, you are going to have troubles. Okay. Here what happens is, spark discharges. Assume there is a pipeline, there is some material which is flowing in that pipeline. What happens is, the pipeline or a plastic hose, when the material is flowing inside the tube, it keeps on rubbing the surface of the tube and finally comes out at the last point. What happens? A pump which is 100 meters away is pumping that material, getting transferred through the pipe, and finally getting discharged at the end of 50th meter in a tank. So the entire charge from the start to the end is continuously rubbing with the pipe, and then coming, while at the point of discharge, it is coming out of the pipe. There you find that this fellow pipe could be at a different charge. The material or the liquid which is flowing will be at a different charge. And at the point of coming out of that pipe, and assume this is a tank where the water is, or not water, say some solvent in a chemical plant or a petrol which is getting transferred. If this liquid, entire liquid is, say for example, continuously charged at some potential, and when it comes and touches this fellow, which is a vessel which is fully grounded perfectly, what happens is this fellow is at some voltage, the bottom vessel is at some voltage. When this guy is going to go there, it is going to create a major spark. So what you need to do is ground everything, this tank, bottom receiver to the pipe, everything has to be grounded so that everyone are at equipotential bonding. Okay. So isolated conductors are different potentials. Energy discharge is just a momentary spark, that's it. Entire energy which was stored over here will get transferred to that. But that spark is more than sufficient to catch fire over there. Okay. Ignition vapor and dust. Ignition vapor is nothing but simple, again going back to the petrol bunk example. Vapor, how many of you have seen that he is having a petrol gun? He keeps the gun inside your vessel. Okay. If you see the vessel, this is a nozzle, this fellow would keep it. At the nozzle, if you see, there will be a sort of a spring which will be wound on that nozzle, and this spring in turn would be going to a black hose. That black hose actually is not just a simple rubber hose, it is a metallic conduit hose which will once again get effectively grounded to the machine over there or to an earth pit which is there at the petrol pump. So when the petrol or diesel is getting transferred, he is going to place it. He will not pour it, he should not even pour it just like this. He should always keep it on the tank surface and then switch on the gun. Then what happens is, by he keeping the gun on the tank, first itself he has ensured that both the surfaces are touching, and then he has pressed the gun. Now the liquid is flowing. So both your vehicle and the gun has now come to same potential. It has connected to earth, and then the petrol is getting filled. You should always ensure this. Even if someone is in your petrol pump in a two-wheeler, when you are standing, if he is just simply going to come and fill it like this, don't allow him. Ask him to keep it fully like this, let it touch the tank, and then you fill it. That is a safe way of filling it. Those people might not know it, but you need to explain. But they, at least 80-90% people are given trained on this. One or two here and there might not really follow the rule, safe practices. So you need to keep that and fill it. That will allow continuous bonding and transferring of this thing. So mitigation is effectively bonding. You need to do a proper bonding for it so as to ensure that it is fully. Next is the brush discharge. Brush discharge is, this can occur from a charged insulating plastic to a conductor. Assume there are some big vessels which are non-conductor by itself, and you have some, all of a sudden, some silos, this type of vessel, and a person coming, or when a vessel is there and internal discharge takes place. Here you can have brush discharge which might take place, and the quantum of joules is somewhere around 4 millijoules, which can get generated during these operations. Next is the propagating brush discharge. Here what happens is, again similarly, when you have a pipe, there both the pipe's surfaces could be non-conductive, but the liquid is conductive, continuously keeps rubbing, due to which charge is getting generated, and finally at the point of discharge, there is a severe generation which can create some ignition taking place. High velocity pneumatic transfers. So here there are certain special principles also saying you should not have very high pumping rate pump for it, meaning I have a big motor which can transfer huge quantity. There are, when you come to static, there are clear specifications saying the pump flow rate should be only so much. You should not transfer very high speed. All these are some criteria which come into picture depending upon the type of material that you are going to transfer. Next is a cone discharge. Cone discharge occurs mainly in, have you seen silos? Silo is something like a big hopper. Okay. What happens in such type of hopper is, my hopper is a very big shell. What happens is, the materials, when it is being dumped from the top, this hopper is getting filled from the bottom. Those materials which are very close to the outer periphery wall is touching the outer wall. So what happens is, this fellow would immediately transfer the charge generated to the body, since the body is at a different potential, and the fellow which is at the center what happens is at a different potential. A mass lump of material falling over here, but my periphery is so big. Okay, so what I will try to do is my charges would try to jump from here to the wall. So the wall surface is at a different potential, material is at a different potential, and there are cases where silos collapse because of this, if you are not properly designed a silo, big silos. So what they do is, all these silos has to have center also too many partitions, so that whatever materials are falling, it is effectively touching. It should not so happen that I am a material, I am touching only another material product, and I am not touching the outer periphery metal part. You should effectively ensure that maximum storage materials are in contact with all the metal parts, for which they will have sort of a partitions, too many partitions in a big silo, so that all products are effectively able to discharge and come to neutral. These are all the various measurement devices that we have in the market. We have electrostatic field meters, then you have surface resistant meters. Surface resistant meters is, static charge is not just only for product, it's even for human being. We need to wear the right shirt, right shoes. You need to, when you go into clean room or static area where you are handling, you might be handling some PCBs. You would have seen what is the static charge symbol. I have not put it over here. Any idea? Static charge symbol, caution symbol. You are going to X-ray rooms, X-ray machine, radioactive symbol. All these has their own symbols for them. Radioactive could be a different way. In a static symbol, static charge symbol, you will have a hand sort of thing in an yellow and a black portion. Only the hand portion would be shown in that symbol. So you just, each one has their own, if such type of symbol is there, it means it's static hazard. Chances that if you are going to touch that, if you see some printed circuit boards, they will be kept in certain covers which will have a symbol clearly saying static charge. By human being touching certain IC, that IC can fail because they are too sensitive. IC meaning integrated chips that we have on the printed circuit boards, PCBs. So that's the reason they always wear something called as wrist strap or static discharge band. This they'll wear like a watch, and from here there will be a button. This button would in turn be having a wire which will go to a earthing strip, so that you are ensuring before we even touching, we will wear this, so that whatever charge we have accumulated in our body will get transferred, and even while handling the card, it is safe to handle, so that no component would fail and all those things. This device is used for measuring the say your clothing, what type of cloth you have kept and what is the resistance, and so as to whether it is safe to wear it in those areas. So mitigation measures, you need to effectively bond it, ground it, and then you need to ensure that the speed restrictions of material which is getting transferred, all those things are restricted to certain flow rate. So all these would help in determining the static electricity generation in any material. Coming to the last, these are all the various products which are available in static electricity studies. You have conductive shoes, you have ionization blowers, you have mats. This is what I told on the band, which will be used in like a wristwatch, and then you have static buckets if you are transferring material from one place to other, all those things. You have various products. Then you have ionization blowers, air blower. Assume this is a clean room and AC sort of material, air is coming continuous. There are chances that this room can get ionized and it's a safe area. So you have deionizing blowers. Ionization blowers are there which will compensate for the this. This is a printed circuit board with a cover. What I told was the static cover, which will thereby safeguard all the IC components and everything, even when you are handling them. And this is a mat sort of. Assume I am going into certain zone. There I will go stand on that mat, check my charge, whether I am safe to go inside. Then once it gives yes, then I will be able to. That's it. Thank you. These are all static. Any queries, questions? I think the PPTs would be shared. Okay. Okay. Thank you.